Today I will guide you through the world of microcontroller programming with Ruby. The title of my talk is A Beginner's Complete Guide to Microcontroller Programming with Ruby. My name is Hasumi. Nowadays, microcontrollers are the brains behind countless electronic devices, from household appliances to robotics, even satellites in the space, right? I hope that my talk is gonna be the very first step for you to start thinking of Ruby on microcontroller. So let's get started. But before, here's what we will cover in this session. Part 1, preparation. Part 2, getting started with microcontroller. Part 3, exploring PicoRuby further. Part 4, PicoRuby under the hood. But before that, let me introduce myself. My name is actually Hitoshi Hasumi. Hasumi is an internet name. I am the creator of PicoRuby and PRK firmware. I will mention it later. I am the committer of CRuby's IRB and Reline. And I was the first prize winner of Fukuoka Ruby Award 2020 and 2022 twice. And I was a final nominee of a Ruby Prize 2 years ago. Because of PicoRuby. Okay, let's begin. In part 1, we will cover the essentials you need to get started with microcontroller programming. Only these 3 things you need: Raspberry Pi Pico and USB cable and a terminal emulator on laptop. In short, just buy a Pi Pico. If you can manage, other RP2040 based controllers should be okay. About Raspberry Pi Pico. Pi Pico is a microcontroller board. MCU is RP2040, whose core is dual Cortex M0 Plus and with 264 KB RAM and 2 megabyte flash ROM. It generally runs without an OS, so-called bare metal. On the other hand, today this is out of scope, but Raspberry Pi, famous Raspberry Pi, is a single board computer. Raspberry Pi generally needs an OS like Raspberry OS or Windows for ARM. And possible terminal emulators option include GTK Term for Linux, Terraterm for Windows, which is made in Japan, and PuTTY for macOS. I'm not sure, I don't use macOS, but it should work. So let's begin. There's 4 steps, only 4 steps. Download the latest R2P2.zip file from GitHub and then unzip it into R2P2.uf2. UF2 means Universal File Format developed by Microsoft, which is a binary format targeting on portability. Then connect Pi Pico and PC with USB cable while pressing the boot cell button. Then you'll find RPI RP2 drive in File Manager. So drag and drop that UF2 file into RPI RP2 drive. Finally, open the proper serial port on terminal emulator. I'll do it. That was terminal emulator. I will connect. Come on. Yeah, this is PicoRuby. And R2P2 shell is a Unix-like shell running on Raspberry Pi Pico, written in Ruby. You can use some commands like, for example, pwd. I'm on /home ls. There's no file. So what should I do? And make dir my dear, ls, okay, touch, my dear, my file, ls, my dear, like this. Oh, date time it's gonna be. I don't know why. Yeah, but apparently this system has a file system. It's also written in Ruby actually. And also R2P2 has IRB because I am an IRB maintainer. IRB, put S, hello world. Yeah. Hello world. Yeah, it is working, right? How do you feel? Okay. Your Ruby snippet is going to be compiled into mruby VM code and executed on the fly. It means PickRuby contains an mruby compiler, which can run on a one-chip microcontroller. I'll mention it later. Okay, part 2. You are now prepared to start playing with microcontroller. So let's dive deeper into handle it. Getting started with microcontroller. GPIO is the most fundamental functionality of microcontroller to operate digital something. For example, you can detect switches and buttons if you use a GPIO in input mode. If you switch GPIO into output mode, you can light an LED. Okay. This is the demo time. What was? LED, GPIO new, okay. LED, GPIO new, 25, is this right? Yeah. 25 is connected to onboard LED. GPIO direction is out. LED, right, 1. Guess what's gonna be happen? Let me see. Oh. And 3 times do LED right 1 sleep 1 LED right 0 sleep 1. So this time, yeah. Thank you. But someone may feel it's kind of magic, right? If you're not familiar with microcontroller. But this is the equivalent circuit. If you using the discrete parts to blink LED instead of using onboard LED, you need only 2 parts, LED and a resistor. I will skip this demonstration, but let me explain the theory. GPIO 15 is here, and the current flows like through and blink LED and go back to the ground. This is the closed loop of the current. You can blink an LED like this. And this is essentially the same as before. RP2040's logic level is 3.3, so the whole of voltage is 3.3. The LED voltage LED voltage drop is 1.8 volt. According to the LED's datasheet, you should read datasheet. So the rest of the voltage should be 1.5. 3.3 volt minus 1.8 volt divided by 1 kilo ohm equals to 1.5 milliampere according to Ohm's law. You can control the brightness of the LED by changing the value of the resistance. Yeah. If you raise up the result of the current, LED should light brighter. Now we are having a study time. Today's lesson is electromagnetism. Okay. The most important thing you're supposed to know is Ohm's law. It tells a relationship between three values. V is a volt. V stands for volt, I stands for current, R stands for resistance. Then the second one is Kirchhoff's circuit laws. What they say? Current law tells that the algebraic sum of currents in a network of conductors meeting at the point is zero. Voltage law is the directed sum of the potential differences around any closed loop is zero. Do you understand? Good. Okay, let's go further. Next thing is ADC, analog to digital converter. ADC handles values from 0 to logic level. It is 1, 0 to 1, by converting an analog voltage to a digital value. For example, RP2040's ADC has 12 bits depth and accordingly takes a raw value from 0 to 4095. The typical usage of ADC should be temperature sensor and joystick on Nintendo Switch and the PlayStation. Okay. Acquire ADC. ADC. ADC new temperature, right? Yeah, ADC read row. It is now 893 out of 4095. While true, V equals to ADC read voltage, this time voltage. Put to S 27 minus V minus 0.76 divided by 0.001721, right? Sleep 1 and okay, let's start. This is the temperature of the chip. Now it's around 20 degrees in Celsius. If I touch the chip, the value should raise. Maybe, I hope. Connection killed. But yeah, I think you know it. I'll skip it. IRV. As in, you can sense a temperature by discrete parts. For example, using a thermistor. Thermistor is a kind of resistor whose values varies according to temperature. This thermistor, let's say, it indicates 10 kilo ohm at 25 degrees in Celsius. The circuit is this, and the program should look like this. Of course, I will skip this time, but you can calculate the temperature by logarithm of math class. Should we have math class? No, enough. Okay. Okay, now it's part 3. Exploring Pico-Ruby further. There is 2 major Pico-Ruby applications, R2 P2. As you saw, it is a Unix-like shell system written in Pico-Ruby. You may want to say an operating system in Ruby. Other one is PRK firmware. It is a keyboard firmware framework for DIY keyboard. You can write your key map and keyboard's behavior with Ruby first. R2P2 has multiple line editor IRB, which is cool, right? 3 times do test hello sleep hello, and this multiple line editor can be edited by like this. Yeah, it's cool, nice. And there are some built-in commands and things like maybe it is no. Built-in command should be written here. Date. Yeah, it's now epoch time of Unix, right? The RTC is gonna be reset every time you plug it in, but I have a possible solution. I will mention it later. Actually, executables are located here. This is built-in commands. Date, install, like this. If you want to see the content of date command, this is not broke, right? This is a binary format of MRuby virtual machine. You can see the word, time, now, 2s, test, right? This is the creator of Ruby, right? Mats. Yeah, I can skip this. Furthermore, you can use a text editor. Vim, hello, RB, test, hello, Ruby, conf, Thailand. Of course, we need to say it 3 times. Escape, colon, W, what? Q. Great. Yeah, this is the file. Hello, RB. Yo. But of course, the Vim is kind of a joke. Of course, you want to use your own text editor, data usage of text editor, right? Yeah, of course you can do it. Just drag and drop. Here's R2P2 drive. Bin directory, home directory. Home directory includes my data. Then you can drag and drop a file. Things like this. Yes. I hope this works. This script sends temperature, and if the temperature is more than 20 degrees, LED turns on, I hope. GPIO and ADC RB. Yeah. Did you see? To be honest, the ADC of RP2 is very bad in terms of accuracy, and it has very high noise floor. So I would recommend to use another ADC. I mean, outside of the chip. But this is enough to explain, right? And yes, if you put /home/app.rb file, it's gonna be started when plugged in automatically. App.rb looks like this. It's a simple with an infinite loop, PTS, and blinking LED. app. Yes, this is the app.rb. I unplugged once. Then replug. Yay! Thank you. By the way, R2P2 stands for Ruby on Raspberry Pi Pico. In the future, I will make that robot work with Ruby. And we don't have enough time, so this is just for your information. And there are serial communication protocols. They are also essentials if you want make a practical microcontroller applications. Now, here I have an advanced example to use, which uses I2C for RTC. RTC has a battery, so we no longer lost the RTC's clock value if you unplugged. And you add. This means you can communicate with microcontroller with USB cable, serial cable. Now, part list. Now, next thing is PRK firmware. Do you build your own keyboard? But less than 10? Are you sure? You are a software programmer, right? Why don't you do that? You should. Actually, I'm not using my keyboard. This is running with Ruby too. This is great, right? This is the sample keymap.rb for Mesh2, who has 4 keys, only 4 keys macropad. In the default layer, that keys is gonna be 0 and 1 and 2 and 3. But if you keep pressing that key, the layer switches to raise layer, and you can control audio. For example, this is how look like this. Okay, the last part, PicoRuby under the hood. As you know, mRuby is a general-purpose embedded Ruby implementation written by Mats. And PicoRuby consists of PicoRuby compiler and mRuby/C VM is another implementation of mRuby targeting on one-chip microcontroller. It focuses on smaller footprint. The VM code specifications are common to both mRuby and PicoRuby, so the compilers are interchangeable. Small footprint, how can we confirm it? It is valgrind. Valgrind -- tool equals massif stack CS path to mRuby or PicoRuby evaluate putes hello world. This command creates massif out process ID. Then you can see the ms underscore print massif out. This is the result of mRuby. mRuby consumes 168 KB of RAM when it runs putes hello world. On the other hand, in PicoRuby, 10 KB, quite small, right? This is because R2P2 can run on Raspberry Pi Pico. Raspberry Pi Pico has only 264 KB of RAM. Only small applications running with mRuby works on Raspberry Pi Pico, I think. But big apps like R2P2 and PRK formulas should be written in PicoRuby. PicoRuby also has an ecosystem, PicoGems. PRK formula is also PicoGems, and GPI libraries for peripherals like GPI or ADC, which I showed you, are also gems. And there is a peripheral interface guide on GitHub, on the mRuby organization of GitHub, for you to make it easier to port to other microcontrollers. Build system of PicoRuby is forked from mRuby. That's written. Yeah. You can build your application in a similar way to mRuby. You can also write your gem and host it on your GitHub. As of now, RP2040 is the only target. You can port PicoRuby to other microcontrollers. Let's do it. Of course, there are some restrictions of PicoRuby. It has minimum built-in classes in the methods. PicoRuby doesn't support some syntax like here-doc and numbered parameters as of now. There's no metaprogramming features, no strict distinction between instance methods and singleton methods, but you can manage it. Also, there are some or maybe many bugs because of me. Please help me. Okay, conclusion. PicoRuby is a Ruby implementation targeting on one-chip microcontroller. Essential peripheral libraries such as GPIO, ADC, I2C, SPI, and UART are ready. You can develop your microcontroller application step by step using the R2P2 and IRB. You need only R2P2 to write small applications. I'm now working on Bluetooth feature for Raspberry Pi Pico W. Before closing it, let me give a quick advertisement from Japan. RubyConfTH 2024 will be held in Okinawa, which is the southmost prefecture of Japan in coming May. There will be more than 1,000 attendees, and with tons of tech talks. Every talk is gonna be technical, like I did today. All Japanese talks come with simultaneous interpretation into English, so you can grab all the talks. And of course, there are various parties. I really encourage you to come to Japan coming May. Yeah. And yeah, Here's the list. Please shoot the QR code if you find my talk was fun. Picorobi/Picorobi is the implementation, the language itself. Picorobi/R2P2 is the Unix-like shell. It is also a framework for application. Picorobi/PRK firmware is keyboard firmware. Picorobi/RP2040 peripheral demo is an advanced example of peripherals. Okay, that's it. That's all. Thank you for having me.